Solution. Magnitude of F1 can now be represented since F1 and F2 are at an angle of 60 degrees. Then it can be represented by the two sides of a triangle, and F3 being the resultant of the force. If Q is 5 Newton, P is 10 Newton, and theta is 60 degrees, using cosine rule, we have that r squared is equal to F1 squared plus F2 squared minus 2F1 F2 cos 120. Capital R is equal to square root of, in brackets, F1 squared plus F2 squared minus 2F1 F2 cos 120, closing bracket. R is now substituting and putting in the values. We have square root of, in bracket, 10 squared plus 5 squared plus 2 times 10 times 5 cos 60 degrees. R is equal to square root of, in bracket, 10 squared plus 5 squared plus 10 times 5 times 0.5. R is equal to the square root of, by doing the sum, we have 175, which will give us 13.2 Newton. Since F3 is in equilibrium of F1 and F2, the magnitude of R is equal to F3 is equal to 13.2 Newton, but the direction of F3 is opposite that of R. Simple harmonic motion. Definition. Simple harmonic motion is the motion of a particle whose acceleration is always directed towards a fixed point, directly proportional to its distance from that point. Summary. In simple harmonic motion, the acceleration A of an object is equal to minus omega squared y, where y is the distance or displacement of the object from the fixed point. The period t of the motion is equal to 2 pi over omega, where t is the time to make a complete to and fro movement or circle. Frequency. The frequency f is equal to 1 over t, and its unit is hertz. The period t is equal to 2 pi over omega, which is equal to 2 pi square root of 1 over g. The magnitude r of the motion is the maximum distance on either side of the center of oscillation. The velocity at any instant v2 is equal to omega square root of r squared minus y squared, close bracket. The maximum velocity v max is equal to omega r. Total energy is equal to half m omega squared a squared. Relationship between linear speed v and angular speed omega is given by v equals to r omega. Linear acceleration a and angular acceleration omega squared is given by a equals to r omega squared. Example 1. A simple pendulum has a period of 2.0 seconds and an amplitude of swaying 5.0 cm. Calculate the maximum magnitude of the velocity of the bulb, acceleration of the bulb. Solution. A. Period t is equal to 2 pi over omega. Therefore, making omega the subject of the formula, we have 2 pi over t, which is equal to 2 pi over 2 is equal to pi per seconds. Velocity v is a maximum at the equilibrium position where x is 0, and plus or minus omega square root of r squared minus s squared, where r is the amplitude. Therefore, plus and minus omega square root of r, which is equal to plus and minus pi square root of 25, which is equal to plus or minus 16 cm per seconds. Maximum velocity v of the bulb is plus minus 16 cm per seconds. B. Acceleration A is maximum at the limit of the swing, where x is r is equal to plus minus 5 cm and A equals to minus omega squared r. Therefore, maximum acceleration A max is equal to minus omega squared times 5 cm per seconds is equals to minus pi squared times 5 equals to 50 cm per seconds. Example 2. Compute the acceleration due to gravity at a place where a simple pendulum 1.59 meter long makes 100 vibrations in 246 seconds. Solution. Period t is equal to 246 seconds over 100, which will give us 2.46 seconds, where t is the time to make a complete circle, but t is equal to 2 pi square root of 1 over g. Therefore, t squared is equal to 4 pi squared 1 over g. Therefore, g equals to 4 pi squared 1 over t squared, which is equal to, in bracket, 4 pi squared times 1.5 meters over, in bracket, 2.46 squared, which we now have 9.79 meters per second squared. Example 3. A steel strip clamped at one end vibrates with a frequency of 20 Hz and an amplitude of 5 mm at the free end, where a small mass of 2 grams is positioned. Calculate the maximum kinetic energy Ke and the potential energy Pe of the mass. Solution. Apply Ke equals to half m omega squared r squared, where omega is the angular velocity and r is the amplitude, but omega is 2 pi f, which is equals to 2 pi times 20. R is equals to 0.005 meters and m equals to 2 grams, which is equals to 0.002 kilogram. Therefore, maximum kinetic energy is equals to 1 half of m omega squared r, which is equals to half times 0.002 times, in bracket, 0.005 squared, which times, in bracket, 2 pi times 20 all squared, which is equals to 0.0003951 joule, or 3.9 times 10 raised to the power minus 4 joule. Maximum Pe, in bracket, V minus 0 is equals to maximum Ke is equals to 3.9 times 10 raised to the power minus 4 joules. Example 4. A mass of 1 kilogram is placed on a horizontal platform, which vibrates up and down with simple harmonic motion with a frequency of 4 Hz and amplitude of 5 cm. Calculate the maximum and minimum value of the kinetic of the mass.